Okay, good morning. So today we're going to talk about valuation of non-market goods. Shh. So there's essentially sort of two ways in which we can value non-market goods. So first of all, as we discussed last time, the problem with valuing non-market goods is we don't observe transactions, we don't observe prices for those goods, so it's hard to figure out what value people or consumers are attaching to them. But we think that valuing those goods can be important. So when thinking about something like clean air, if we want to think about what is the potential cost of a polluting activity, we need to know what the value of clean air is, what the value of the good being destroyed or consumed is. And so there's two ways that we're going to discuss that economists use to try to value goods that aren't traded openly on the market. So one is called revealed preferences, and basically, so we're going to talk about some detail, but basically the idea behind revealed preferences is that in some cases we observe transactions of goods that have certain like attributes or certain public goods like bundled with them. And so in that case, we might be able to make inferences about the value of the public good that's bundled in with the good that's being traded on the market. So I'll give a much clearer example of this during the lecture. And then the second way, which we'll get to towards the end, is called stated preferences. And stated preferences is basically just saying, well, we're going to just go ask people what they, what value they place on goods. So that's very sort of easy from an implementation standpoint and from a conceptual standpoint. But there are some serious issues in terms of whether or not we trust the valuations that we get from asking people, how much they value clean air. So also with this one, I'm going to distribute a survey. I think maybe not in class. I'll just have it as like a super short assignment. This will only take you like 5 minutes. So it's just going to be a super short assignment that's due on Friday. So I'm going to distribute a survey, post it on B-Courses. You guys fill it out, bring it back. Maybe if I can set it up online, I'll even just do it online so you don't have to bring it in. And then we'll tabulate the results as well. And you'll sort of see how different issues interact with the stated preferences design for these surveys and potentially generate different answers depending on how you frame the questions. So that's the game plan. The other thing that I should mention is that I did post the first problem set this morning. So you can go on B-Courses and download it. It's not super long. It's like 5 or 6 true-false questions. You don't just answer true-false, though. You need to actually justify your answer with several sentences. And that's going to be due in a week on the next Wednesday. And pretty much certainly by the time we finish today, you will have covered all the material you need to answer the questions in that problem. Okay, so in terms of thinking about valuation of non-market goods, there are essentially two common methods that economists use. So the goal here is to measure either somebody's willingness to pay, so the question of like how much would you be willing to pay for or to obtain an environmental good, or alternatively the flip way of looking at it would be to think about willingness to accept. So this is asking how much would you need to be paid to give up the environmental good. So basically, sort of from a property rights perspective, we can either think of you having been assigned the good in the first case, and then we're going to pay you to take away the good, or the good has not been assigned to you but belongs to somebody else in the second case, and then reverse. So willingness to pay would be the good is assigned to somebody else, and then you have to pay in order to get it, and then the second one, the good is assigned to you, and then somebody else has to pay you in order to get access to that good. So as I said, there's two common methods. One is called revealed preferences, and we'll talk about that in detail. Then the other one is called stated preferences. Sometimes you'll also hear refer to as contingent valuation. So contingent valuation, stated preferences, basically are synonyms from our perspective. So the method of revealed preferences leverages situations in which non-market goods are associated with market transactions. So the idea here is that in these transactions, we might be able to infer the value of the non-market good if we make some assumptions about the market good that's being traded. And then in doing so in engaging in these trades, people are going to, quote unquote, reveal their preferences for these non-market goods. So a very sort of simple example of the revealed preferences method is what's known as the travel cost method. So the idea here is that in some cases, if you're thinking about like recreational value of a national park or coastline or something like that, in many cases, people don't actually live in the national park or on the coastline, and so they have to travel in order to get there. And travel obviously involves money, both in terms of time and in terms of actual dollar cost, because you're paying for gas and putting wear and tear on your car and so forth. And so we can make inferences about at least the minimum value that people place on the recreational opportunities afforded by the national park or the coastline by looking at how much they're willing to pay in order to travel there. So you could ask the question, well, how much do I value, say, Mendocino coastline, which is about a 3 or 4 hour drive up north from here? And so I did the calculations a few years ago when we visited, just for the purposes of this example. I mean, we didn't visit for the purpose of this example. I did calculations subsequently for the purpose of this example. And so I think it cost me something like $75 in monetary costs, and then about 6 hours of time if you're thinking about the round trip drive to travel there. And as I mentioned, so there's always a question of like how do you value time, and it's not entirely clear. Like even introspectively for yourself, you probably would have some difficulty putting an exact dollar value on time. But if we valued my time at like $50 an hour, say, then my use value of the Mendocino coastline would have to equal or exceed $375. Now you could set a higher or lower value, but you sort of end up with a range of estimates then. So if you said like $20 per hour, then you'd have 120 in time value plus 75 in monetary cost. That would be about $200 minimum. If you said higher, then obviously it would exceed the $375. But the key idea here is that if I didn't value it by at least that much, then presumably I wouldn't have traveled there. So we're assuming that people are actually making informed, rational decisions and only choosing to go if they are getting some sort of positive utility out of this after netting out the costs. So I think that's sort of one of the simplest demonstrations of the revealed preferences methodology. But something that, it certainly has been used in the literature, but you're kind of limited here in terms of how many like opportunities there are. It just basically has to be something about like you have to be measuring like the recreational value of some site that's not too close to where people live. But once you get beyond that specific context, the travel cost methodology usually doesn't apply that much or apply that many cases. So a much more common example that that gets applied in the literature or gets used in the literature is what's known as hedonic pricing. So you'll often see this method used either with housing or with jobs. So the intuition here is that a good, so in this case either a house that somebody is thinking of buying or a job that they're thinking of taking, has multiple characteristics, and consumers are going to assign value to each of these specific characteristics. So let's just take housing as the case that we're interested in. So somebody's going to choose whether or not they want to buy a house, and they're going to sort of pick a neighborhood and look at houses and decide whether or not they want to buy one. And so there's a lot of different things that you sort of assign value to when you're thinking about buying a house. So you look at the number of bedrooms, the number of baths, the square footage, what kind of views you have from the house, the air quality, school district quality if you have kids, turns out to be a huge one. Crime rate, obviously you want to have relatively low risk of getting mugged, and more sort of generic curb appeal, the size of the lot, and so forth. So the the idea is that if different houses have different sets of characteristics, then we might be able to estimate the effect of each characteristic on the market price of the house. So one example would be if we're interested in estimating the value that people place on clean air, we might compare houses that are in low pollution neighborhoods versus those that are in high pollution neighborhoods while controlling for other characteristics that we observe about the house. So you wouldn't want to do just a direct comparison of, say, houses in a high pollution neighborhood versus houses in a low pollution neighborhood, because there's probably like a pretty different housing stock in both of those neighborhoods. So you might find, for example, that when you're looking at the low pollution or the high pollution neighborhood, probably that's going to be a poorer neighborhood. Maybe the houses will tend to be smaller. There might be, fewer bedrooms and bathrooms per house, smaller square footage. The upkeep might be worse. But fortunately, those are all characteristics that you can observe in the data. So if you get transactions data from the county assessor, which I have done for various research projects, they tell you not just how much the house was sold for, but also a whole bunch of characteristics like the size of the house and the number of rooms and bathrooms and bedrooms and so forth. So you can actually essentially control for those characteristics in regression and do comparisons between houses in low pollution neighborhoods and high pollution neighborhoods while trying to essentially hold these other characteristics fixed. That being said, there are other differences between the houses that are going to be more difficult to control for. So for example, school district quality, you would typically assume probably that's going to be better in the low pollution neighborhood than the high pollution neighborhood, because the low pollution neighborhood is probably going to be like in the suburbs or something. The high pollution neighborhood is going to be next to whatever, like a Port of Oakland or something. The reason, so you can of course observe school district quality, and you could potentially also include that as a control in your regression. Now, I understand we haven't actually covered regression yet. We're going to do that at some point. Hopefully some of you have been exposed to it in econometrics or statistics, but if not, just sort of don't worry about it too much at this point. We will talk about it later. But the issue with, once we get into things like school district quality, the thing that makes it more difficult here is that that's something that only varies at a sort of a higher level, right? So you don't necessarily have a lot of variation in school district quality that's going to be independent of the variation with air quality. So in the worst case scenario, what you might find is that like all of the high pollution neighborhoods have bad schools and all of the low pollution neighborhoods have good schools. And in that case, then when you observe differences in house prices between the high pollution neighborhoods and the low pollution neighborhoods, you're not going to be able to infer whether that's because of the pollution or whether it's because of the school district quality or whether it's some combination of the two. So this specific example, I think you can sort of theoretically see how it might be possible, but in practice it could be difficult depending on what kind of data you have. So a real example of hedonic pricing. So this is a specific example using two houses that were sold several years ago, but it kind of relates to an actual economics paper that was written back like circa 2000. And so in this example, what we do is we compare two houses that are one block apart but in different public school districts. So the idea here is now that we want to get an estimate of how much people value public schooling. So that is, public schooling is like it doesn't necessarily have to be a public good, but we provide it as one. It would be excludable and certainly rival in the sense that if you attend school, if you're occupying a seat in school and somebody else can't occupy that same seat, but for which would be pretty obvious reasons, we decided to have free compulsory public education. So it's not something that we actually see people transacting on the market. You don't really buy a place in a public school district because it's freely available to you, assuming that you live within the catchment area. But we might want to figure out sort of how much people value having a better school district versus having a worse school district. And so the comparison here, which some of you might be familiar with, is yes. Right. So that's the whole point, is that essentially the house you can think of as being bundled with this public good, which is the school district. And so by looking at the value of the house, we can infer people's willingness to pay for the school district. So for those of you who are not aware of like the geography at play here, so here's like we are in Berkeley, and then and here's like the bay. Ignore the fact that Berkeley doesn't always go all the way to the bay there. And you have Oakland, of course, to the south of us. And then somewhat oddly, so I'm sure it's not the only one, but it's kind of unusual. So you have the small town of Piedmont, which is actually its own city. And it is entirely surrounded by Oakland, and it's not very large. So this is just for historical reasons. They, I think probably sometime back in the 1920s or something, they had an opportunity to join in with the city of Oakland if they wanted to, or they didn't want to, and now they're their own little separate city entirely surrounded by Oakland. And so it's kind of become an enclave of like relatively wealthy families, and so you have this cluster of relatively wealthy families who, of course, are able and willing to fund their school district to a higher level on a per capita basis than Oakland is able to fund it, given that the average income in Oakland is substantially lower than the average income in Piedmont. So basically, the Piedmont schools are substantially better than most of the Oakland schools. So there's a very sharp change in the quality of the school district as you cross that border, but it's actually not really apparent otherwise that you are crossing the border. I mean, it depends on maybe which direction you're coming from, but in a lot of cases, it's like the Oakland block that's right here on one side, on the Oakland side of the border, really doesn't look all that different from the Piedmont block that's right on the other side of the border. So you don't have much of a change in any other attribute as you cross this border other than the quality of the school district. So what we do, or what I'm doing here, is basically comparing a house that's on the Piedmont border to another house that's very close, that's on the Oakland border. So the nice thing about that is we know that almost all of the other neighborhood characteristics are going to be identical between those two houses. So certainly like the air quality is going to be the same. It's not like the air stops circulating right at the city, right at the political jurisdiction border. Crime rates are probably pretty similar. I mean, there's probably maybe like a modest impact because Piedmont does have its own police force, and Oakland's police force is probably overworked. So there's probably, I'm sure there's more responsiveness to like a burglary on the Piedmont side relative to the Oakland side, but it's not clear exactly what the deterrence effect is. So certainly Piedmont has plenty of burglaries as well. So you wouldn't necessarily think that like crime rates are all that different even as you cross the border. The streets basically look the same on either side. So really what you're getting there is just a sharp change in the you're like isolating a sharp change in the quality of the school district. So this is just picked off of probably like Redfin, I think, several years ago. And the house that's on the Piedmont side of the border had 2 bedrooms, 1 bathroom, 1,235 square feet. So it's pretty small for a house. And it sold for $740,000 in 2010. That works out to like $600 per square foot. That sadly now, that would probably be almost close to $1 million because the real estate market is going crazy. And frankly, I don't think it has like that much curb appeal. So I took the picture off the website as well. I know that's fine, but it doesn't look like spectacular. So in comparison, the Oakland house actually is better on virtually every dimension. So the Oakland house turns out to be much larger. It's 3 bedrooms, 3 bathrooms, and almost 2,200 square feet. And it sold for pretty much the same price back in 2010, so $708,000. So in terms of the raw price of the house, they're pretty comparable. The Piedmont one was a little bit more expensive, but once you think about it on a square footage basis and basically adjust for the fact that the Oakland house is much larger, you can see that the price is like much lower. It's like basically about half, $330 per square foot, instead of around $600 per square foot. And frankly, it looks like a better house going from the curve. So you can see that there's this huge differential, at least on a square footage basis, in the prices between those two houses. And I can tell you basically that's all just the value that people are placing on the school district. So pretty much nobody who doesn't have kids at schooling age is going to choose that Piedmont house there because they wouldn't actually get any value out of that the school district. So they certainly the whoever ends up buying on the Piedmont side almost surely has kids, and then on the Oakland side they might or might not have kids. It depends. So the price difference is going to the price difference between two houses is going to reflect the value the buyers are assigning to the schools. And again, on pretty much every observable dimension, the Oakland house looks better, and both houses are in the exact same neighborhood. The really distinguishing difference here is which side of the school district boundary they lie on. So we can conclude. So I don't have like a specific. We could sit here and try to work out exactly what the implied value of the school district is to the buyers. If we wanted to do that, it would be better to really mine the data more carefully and try to find two houses that were, in fact, the exact same size. So, like, I went in and I wanted to find two houses that were geographically proximate, so those two were really just a block or two apart. And so I didn't sit there and try to go through all of the geographically proximate pairs, one on one side of the border, one on the other, and then find two that actually had, like, the same number of bedrooms and bathrooms and so forth. I'm sure if we went back in historical data, like, far enough and looked enough, we could find two that looked very similar in terms of their observable attributes, and then, of course, had very different prices. So if we wanted to really sort of estimate how much people are valuing to get like a numerical estimate of how much people are valuing the school district, we would want to do that and then look at the Piedmont house. So that one was $740K, just based on square footage. My guess is an Oakland one that, at least at that time, that had similar attributes in terms of square footage and stuff would probably be something like $400K. So you'd probably get somewhere around a $300,000 implicit valuation of the public schools. The other thing that you would need to know, though, of course, is how many kids on average are the buyers on the Piedmont side, and how many kids are in the family, right? Because if it were just one kid, then you would say, oh, they're valuing the educational slot for that one kid at $300,000. But if it's two kids, then presumably you need to divide by two, and it would be more like $150,000 or so. I should also say, so I also have like two colleagues who live very close to each other, one on one side of the border and one on the other. So basically, one of them has two kids, and so she lives on the Piedmont side of the border because if you do the math, it's cheaper to buy. So obviously, it's more expensive to buy a house on the Piedmont side border, but with two kids, it's cheaper to buy a house on the Piedmont side of the border than it is to pay to send two kids to private school. My other colleague only has one kid, and so he lives very close to her, but on the Oakland side of the border. And the same thing is at work here in the sense that, like, okay, so it's cheaper to buy on the Oakland side of the border, so he saves money doing that. Then he's going to send his kid to private school, but he only has one kid, so on net he ends up better off than having paid the premium on the Piedmont side. So even just the number of kids can basically determine which side of the border you end up living on there. Okay. So that's a very concrete example of applying the hedonic pricing method to try to measure people's willingness to pay. But we can express the hedonic pricing method mathematically as well in a more abstract way. So we can think about basically the price of a good as being a function of various things. So I'm going to write down x, z, and e here. So p is the price. So f is just some arbitrary function. We haven't specified a functional form here. But p is the price. X are going to be the characteristics about the house. So these would be like house-specific characteristics like square footage and number of rooms and things that are the characteristics of the house itself. Then z would be neighborhood characteristics. So those also apply to the house, but they don't vary at the house level, right? So it'd be like the school district you're in, the crime rate of your neighborhood, the pollution level in your neighborhood, that type of stuff. Or actually, sorry. So the pollution, we would then put in E, which are the environmental characteristics. So the price is going to be a function of all of these things. Obviously, you want a bigger house in general, you want better schools in your neighborhood if you have kids, lower crime rate, and then you want like cleaner air. So then we can express the marginal willingness to pay for the environmental good, which is E. So if we're thinking of it, say, cleaner air, that would be expressed as the derivative of price with respect to the environmental good, which would be the f of x z with respect to d. So in practice, that function that I wrote up there, it could be nonlinear, and furthermore, the derivative of the price with respect to the environmental good could in fact be a function of x. So what that's saying is that your willingness to pay for the environmental good might actually be affected by the characteristics of the house, or might at least vary with the characteristics of the house. And to see why that could be, you could think of an example, say, of houses with large number of bedrooms. Right? So x is the characteristic of the house, so x could be the number of bedrooms. And those houses, they might be bought or purchased by households that have a higher willingness to pay for clean air, so higher DP with respect to D, or DP or DE. Since the larger families are presumably going to benefit more from a clean environment than the smaller families, right? Just in terms of like if you have 5 family members and you're valuing clean air at $X per family member, then the household as a whole is going to value clean air more than a household that just has one family member and values it at the same amount per family member. On the other hand, it could also be the case, so as I said, the function here, that function f of x, z and e could be nonlinear. So it could also be the case that dp/de could be decreasing in the environment, or in e, if environmental improvements don't matter as much after you pass a certain point. So what I'm saying there is that the second derivative could be negative. The first derivative itself, dp/de, would probably never be negative. It might hit 0, but it's not clear why you would ever place a negative value on having an even cleaner environment. But the second derivative might be negative. So essentially, you might get to a point where you've cleaned up the air so much that you don't place any additional valuation on getting it even cleaner. Once you're down to 1 part per billion or something like that, getting down to 0.5 parts per billion or something might not be something that you want. So you don't necessarily want to think of this function f of x, z, and e as being just a simple linear function. That being said, for estimation purposes, a lot of times once you actually get data on x and you get data on z and you get data on e and then you have data on p on prices, you might end up specifying p as a linear function of x, z, and e just because for estimating a regression, for estimating like a